Okay, so now that we've actually used the calculator, I'm going to pull that back up to find our line of best fit. Notice on this occasion, I don't have the R value, so that's because my calculator was reset and I need to turn diagnostics back on. So I'm going to quickly go down here and turn my diagnostics back on. You should only have to ever do that again if your calculator resets. So I'm going to go back to stat one more time. So stat, I've already entered my data, so my data is still there. I'm going to go back to stat one more time, go to the right over to calc, and then we're going to go down to linreg, which is line number 4. So if you want to do it a little bit quicker, you don't necessarily have to scroll down. You can just hit the number 4 right away, and it'll choose that option. So now I'm going to click enter, go all the way down to calculate, and hit enter one more time. So now you can see that I am getting this R value here at the very bottom. Let me pull up the large screen as well. You're getting this R value here at the very bottom. So the three things we care about, you do not care about the R squared. This R squared is something you're not going to use until maybe if you take AP Stat. But in this particular course, what you care about is your A value. And I wanted to discuss this earlier. The A value, why Texas Instruments, the maker of this calculator, didn't choose the letter M, I don't know. But it really does represent the letter M. Your A value is your slope. Your B value, like we've been practicing, is your y-intercept. So that creates our equation y equals mx plus b, in this case ax plus b. So our equation in this case, I'll even write it down here. You can just write it down with me if you'd like. Our equation in this case would be, write it off here to the side on the bottom, y equals, look at our equation. So y equals, come back to it one more time so you can see what I'm talking about. Negative 2.6. So negative 2.6x. And then our b value is 12.5. So plus 12.5. So our line of best fit is always going to be an equation in that form. Now, if you have a lot of decimals, round to the nearest 2 decimal places. So I'll try to do an example with one of those later. But that's our line of best fit. Now, I want to talk about one more component that's on this screen, and that's the R value. I've started to talk about it, but what that R value represents, in this case, it's negative, so don't miss that negative 0.9970, goes on forever. What this R value is doing is it's basically giving you a grade on how good your line is, how good this line is that it just created for you. So basically, when you take a test, right, we give you a grade on how well you did, how well what you did fits what we've tried to teach you. Okay, this is the same thing. The R value gives you a grade on how well this equation, this negative 2x, negative 2.6x plus 12.5, actually fits the data that we created. So in this case, our grade is actually very, 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 very good because it's very, very close to, in this case, a -1. So there's that negative there. So it's very, very close to a -1. So I want you to look at your notes and see here that we have this kind of spectrum. There's not much to write here, but I need you to understand what it's saying. So when we're talking about the R value can range anywhere in between -1, like our example did, all the way to +1. Okay? So it's never going to go below -1. It's never going to go above +1. So it's really important for us to understand what it's actually telling us. So let's just take that R value that we were using. Our R value was about -0.997, something like that. That is so, 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 so close to -1. So what that means is that this is a very strong, 2 words here. This is a very strong, so I'm going to highlight that one. And we're on the negative side because it was negative 0.997. So it is a very, very strong negative correlation. Okay. Now, what if we had an R value that was, let's say our R value was 0.87? Well, 0.87 places us somewhere probably right about here. So this would be a strong as well, also strong, but in this case, strong positive. So if you are close to -1 or if you're close to +1, both of those are strong. Just one is positive, one is negative. It's only when we start moving towards the middle, when we start moving towards 0, that our correlation or the relationship, the measurement of how good a fit this is, starts to get weaker. So some examples of weak correlations: 0.3, that's a very weak correlation. -0.25, a very weak correlation. These are weak correlations. Basically, what it tells us is that if we were to get that correlation coefficient, the R value would not be applicable. It really shows us that that line of best fit is actually not a very good fit at all. So just like if you were to get a 25% on your test, that would mean that you really did not match what we were trying to teach you, did not learn what we were trying to teach you. So that's really what the R value is trying to communicate. It's trying to communicate to us the what it really represents. So it's going to be very important for us to understand how the R value helps us manage and kind of classify what um, what our line of best fit, how good a match it really is. So it's just a quick note on the R value.